Hello dear friends, in this video I am going to explain the voltage divine formula or voltage divider formula for simple 2 and 3 resistors in series. So always remember that voltage divine is applies in for the series circuit, the resistor that are in series, because if the resistors are in parallel, so across the parallel resistors the voltage will be the same. Okay, for the 2 and 3 resistors. Okay, so first thing, this voltage divider formula for the two resistors. So if we have two resistors R1 and R2, and we want to find the potential drop across R1 and the potential drop across R2, that is represented by V1 and V2. The source voltage or the total voltage of the battery is V. If total source voltage is V, that is coming. So as we know that the according to Kirchhoff voltage rule, this total potential is divided into equally in between R1 and R2. R1 and R2. It depends on the value of their resistors. Okay. So the basic formula is the voltage drop across V1 that is equal to same resistance R1 divided by total resistance of the circuit, mean the R1 plus R2, and we multiply with the source voltage, that is V, total voltage from the battery, that is V. Okay, now for the voltage across V2, voltage across R2, we use formula same resistance R2 divided by same resistance R2 plus the other resistance that is in series with R2, that is R1, and we multiply with the source voltage V. So that the basic formula is voltage drop across any resistor Vn is equal to the value of that resistance Rn divided by value of that resistance Rn plus the plus the network resistance, sum of all other resistance in series, network resistance in series. So remember that all other resistance must be in series with Rn, this specific resistance. For example, if you want to find the voltage drop across R1, so that the R1 and R2 must be in series, so that we can find the potential drop. Okay, so let us take a simple example. For example, we have two values of voltage resistance, 20 ohm. R1 is 20 ohm and R2 is 30 ohm, and the source voltage or the battery voltage is 25 volt battery. We attach 25 volts battery. Now how the we can find the this voltage? Okay, so in order to find this one, we use formula for the V1 which is equal to R1. So the R1 is 20 ohm divided by same resistance 20 ohm plus the network resistance with the other, that is in series. So 20 and 30 is in series with the 20, so we have 30 ohm. So we multiply with the source, our total potential from battery, that is 25 volts. So we get the answer 20 over 50 multiplied by 25, we get 2 and then 10, then 30, 50, 22, the 10 volts. So similarly, a voltage drop across V2 R2 is equal to the same resistance R2 across V, which we want to find the voltage. So 30 ohm divided by same resistance 30 ohm plus the other network resistance, I mean the total the resistance that is in series. So R1 is 20 ohm. We multiply with the 25 volt, the source voltage. 30 divided by 50 multiplied by 25. Now we get 15 volts. Now you can check this. So total voltage across V1, del V1 plus del V2 must be equal to the source voltage V. So you can check, it's a quick check. Total voltage V is equal to del V1 plus del V2. That is equal to voltage across V1 is 10 volts voltage across V2 is 15 volt. Now it is a quick check, you can say that 25 volt. So the source voltage is also 25 volt, and the voltage drop across R1 and R2 is the same, that is 25 volt. Okay, so this is for the resistors having two resistances R1 and R2 in series. So now if we have three resistances R1, R2, R3 in series, so suppose that R1, R2 and R3. So we want to find the potential drop across R1, R2 and R3, that is represented by V1, V2 and V3. So we use the same formula. So voltage drop across any resistor N is equal to same resistance divided by same resistance plus the other resistance, network resistance in series. Network resistance in series multiplied by the source potential or total potential from the battery. So in order to find R1, let us take a simple example. For example, if we have three resistors, 10 ohm, 20 ohm and 30 ohm, and the source voltage or the total voltage is suppose 30 volt, and we want to find the potential across V1 across R1, that is equal to del V1 or V1 simple. So in order to find V1, we use formula same resistance in which we want to find the potential, the resistance R1 divided by same resistance R1 plus other resistance. As we know that R2 and R3 are series with the R1, so network resistance is R2 plus R3, R2 plus R3, and we multiply with the source voltage 30 volt. Okay, so R1 is 10 divided by 10 plus 20 plus 30, and we multiply with the 30 volts, that gives us 10 divided by 30, 20, 50, and then 60 multiplied by 30, so it will get 2. 10 divided by 2, that gives us 5 volt, that gives us 5 volt. Okay, now del V2. So in order to find del V2, we use same resistance R2, we use same resistance R2 divided by same resistance R2 plus network resistance. So as we know that R1 and R3 are in series with R2, so network resistance is R1 plus R3, and we multiply with the source potential, the total potential from battery, that is 30 volt. Okay, now R2, so R2 is 20 divided by 10 plus 20 plus 30, we multiply with the 30, so 20 over 50, 60 multiplied by 30, so 20 by 2, that gives us 10 volt. Now finally del V3 is equal to R3 divided by R3 plus R1 plus R2. Similar fashion, we multiply R3 is 30 volt, 30 ohm divided by 30 ohm, R1 is 10 ohm and R2 is 20 ohm, and we multiply with the source battery voltage, that is 30 volt. So 30 divided by 60 multiplied by 30, so we get 30 by 2, that gives us 15 volt. Okay, del V3 is 15 volt. So you can check V1 plus V2 plus V3, so that you can, it's a quick check, you can check your answer by adding all these three voltages. So you can check that V1 plus V2 plus V3. So V1 is 5 volt, del V1 is 5 volt, del V2 is 10 volt, 10 plus 50, and del V3 is 15 volt. So you can check when you add these three voltages V1, V2, V3, it gives us a total accurate potential, the source potential, that is 30, 5, 10 and 15. So that the 5 volt plus 10 volt plus 15 volt is give you 30 volt. Okay, so this is basically this is the simple formula. Now you can apply it for the simple complex circuit. For example, we have, let's take another example. For example, so basic rules are clear. The voltage divider formula is applied on the circuit, that the resistors must be in series. Okay, so let's take another example. So R1, for example, 6 ohm sorry, R ohm is 3 ohm. Sorry, take example 3 ohm. R1 is 3 ohm, and R2 is 1 ohm. R2 is equal to 1 ohm, and now R3 is R3 is equal to, for example, suppose it is 5 ohm, and R4 is equal to, suppose R4 is equal to 3 ohm. Okay, now, and we want to find the potential drop across, for example, the 10-volt potential is drop across the circuit. Okay, so let's think about this. So basically, first R1 and basically R4 and R3 are in series, in parallel combination. R4 and R3 are in parallel combination. So first we solve this network. First we solve this network into simple one, because you know that R2 and R3 are in series. First we add them, so we get R2 and R3. So 10 volt R1, 3 ohm, so we have 3 ohm. Now we have this. When we add 1 plus 5, that gives us 6 ohm. 6 ohm. We solve it 6 ohm. Now 3 and 6 are in 3 and 6 are in parallel. So we solve 3 and 6 that are in parallel. So we get any value, that is 3 and 6. 3 ohm parallel to 6 ohm. So it will give us 3 into 6 over 3 plus 6. So 18 over 9, that gives us 2 ohm. So now 2 ohm. Now you can see that this 3 ohm and 2 ohm are in series. Now we can apply simple voltage divine formula. So in order to get the voltage across 3 ohm, so we use formula voltage across 3 ohm. Suppose this is V1. Suppose this is V1. So V1 is equal to R1 3 ohm divided by 3 plus 2, and we multiply with the source potential 10 volt. So 3 over 5 multiplied by 10, that gives us 6 volts. So that voltage across 3 ohm is 6 volt. 6 volt. So similarly, V2 voltage drop across second resistor is 2 ohm divided by 3 plus 2, and we multiply with the 10 volt. We get 2 over 5, and we multiply with the 10. So it will give us 5 to that, so 2 to the 4 volt. Now it means the 4 volt drop across this 2 ohm resistor. Okay, so if we can check the complex network, so you can say that voltage drop across R1 is 6 volt, and voltage drop across this network is 4 volt. Across this network is 4 volt. This network is 4 volt. It does mean, so we need more information about this. Okay, so basically there you can solve any circuit by replacing it in the series circuit, then we can find the potential drop across. Okay, thank you.